Squares and square roots. Some of the most important things to remember about squares are perfect squares. So, for instance, perfect squares consist of things such as 1 times 1 is 1, 2 times 2 is 4, 3 times 3 is 9, 4 times 4 is 16. I think you might get the point. But perfect squares are those answers to what a number is times itself. So, there's plenty of examples out there. You guys know plenty of them. So perfect squares are just those final answers to a number times itself. Now the next thing is a square root. And a square root is the opposite of a square. What a square root is you're taking and figuring out what number times itself gives you the answer underneath the square root sign, which what we call the square root sign is a radical sign. And as you can see, it looks similar to a division sign, but it's got an extra little V type shape on the end of it. But some examples, if we have a perfect square such as 36, and we try to take the square root of it, we need to find out what number times itself gives you 36. So 6 times 6 is 36. So the answer to a square root is 6. Okay, another example, 9, square root of 9. So 9, what do we multiply by itself to get 9? So 3. So the square root of 9 equals 3. Now there's some other examples. When you have something out front of a radical sign, remember that's what the square root sign is called, such as a negative. So negative square root 64. Well, we find what the square root is within the radical sign. So what is the square root of 64? Well, 8 times 8 is 64. So the radical of 64 is 8. But we have that negative sign that we cannot forget. And because the negative sign is out front, it's almost like there's parentheses there. So that square root sign, you can kind of think of it like you do with parentheses when it comes to a negative being out front. That negative just attaches itself to whatever the square root is. So since we said what's the square root of 64 and we got 8, the answer to that particular problem is negative 8. Another example down here on the left is plus or minus sign. Now it looks kind of funny, but all it means is both positive and negative. So both positive and negative square root of 4 equals, again, we just keep whatever the sign is that's out front. So positive, negative, 2. We actually just call that plus or minus. Another example is if we have a square root and we have a negative underneath the radical sign. So such as this example, negative square root of negative 81. Because the negative is underneath the radical sign, the answer is no real numbers. Because we cannot take the square root of a negative number. You can plug it into a calculator, and a calculator will not be able to give you an answer to that because there are no real roots. And that's when you get into some other details that you'll get into in possibly late Algebra 1, definitely Algebra 2, where you start talking about different kinds of numbers. When you're trying to estimate a square root, meaning that you're just looking at it and trying to identify where it could possibly be or what it might be between. So, for example, if we have the square root of 33, then we need to identify what two perfect squares the number under the radical sign is between. So the number under the radical sign in this example is 33. So what two perfect squares is 33 in between? If we look at it, it's between 25 and 36 because 5 times 5 is 25, 6 times 6 is 36. So there's not one in between there that's a perfect square. So once we identify what it's between, then we need to see which one is it closer to. Is it closer to 25 or is it closer to 36? In this case, it's only 3 away from 36, so it is closer to 36. So when we estimate the square root, we would say that the square root of 33 is approximately 6. And that's what that squiggly equal sign equals, is approximately. Another example, 129, but remember it's got that negative sign out front, and all we need to worry about is dealing with that at the end. So we deal with what's under the square root first. So 129, if we're estimating this, we say, well, it's between 11 times 11 and 12 times 12, which is 121 and 144. Which one is it closer to? Well, 129 is only 8 away from 121, but it's much more of a difference between 129 and 144. So we know it's closer to 121, and the square root of 121 is 11. So the approximate value of the square root of 129 is 11, but remember we have that negative sign that's out front, so we need to attach it to the end. So our answer should end up being negative 11. The biggest thing that you need to remember are those perfect squares, and if you need to, you can always write those down and identify what they might be. Within this table, as you can see, I've included perfect squares from 1 times 1 all the way to 20 times 20. Obviously, there's more past 20 times 20. You can do 21 times 21, 70 times 70. It's a big world of numbers there. You can go all the way, as many numbers as you can think of. Perfect squares don't end, just like numbers don't end. So you can always use this chart, or realize that you can go past this chart using numbers that follow it.